All right, so I'm Jamie Burke. I'm going to be talking about the Tom Toolkit and a Tom that I've been building called the Supernova Exchange 2.0. So one slide of background on the original Supernova Exchange, aka SNEX. SNEX is a Tom, a target and observation manager that's used by the Supernova group at Las Cumbres Observatory, of which I'm a member. I'm a grad student there. It's also used by a larger collaboration, the Global Supernova Project. It's a website, supernova.exchange. Here's a screenshot of it, similar to the one that Andy showed a couple talks ago. For each supernova that we follow, it gets its own target page where you can write comments, you can see its visibility, assess recent data you're getting, schedule observations, do a bunch of good stuff with it. SNEX was written by a former postdoc of the group, and once he left the group, development on SNEX slowed considerably because he was the only one who really understood the code base deeply. So a large project over my PhD has been to rewrite SNEX into SNEX 2 using the Tom toolkit, which we've already heard quite a bit about from Rachel and David and Curtis. So most of this talk will be a walkthrough, so let me start this video. Here's the homepage of SNEX. It's currently live at test.supernova.exchange. We're still porting stuff over from SNEX 1 to SNEX 2. We've customized it considerably from like what you get out of the box with the Tom toolkit. So you'll see some of that. I'm going to do most of this on a local version that's running so that I don't mess up our production DB. If I go over to the targets page, you'll see all these plots loading in asynchronously. So these are all the targets that are in my Tom. For each target, you can at a glance see its photometry and spectroscopy and visibility. If I want to add targets to my Tom, a couple different ways to do that. So I'll show off one way. If I already know a target, I can query any one of a number of services. So I'll just put a name of a target that I already know is interesting in there, and query the TNS. That'll go and get the RA and DEC for the target. I'll scroll down to hit submit and make a new one. You can also see a bunch of groups listed here. So for each target, you can specify if it's only visible to certain users, certain sub-collaborations. So there you go, a new target has been created. The reason that took a second is if you go and look over to the left, you'll see a bunch of different names there. So those were all names that were accessible by the TNS API, so it pulled those in. And then with those names, it also pulled in all available data it could find. So since there was a Gaia name, it automatically pulled in Gaia photometry. Since there was a ZTF name, it also automatically pulled in ZTF photometry as well. So it collected all available photometry that it could find. If you don't a priori know a target you want to add, you can query a broker. So here are a bunch of brokers you can use. I apologize if yours isn't on the list. I'm going to use Alerce for this example. So I like Alerce because it has this built-in classification probability that we've already heard about. So that makes it a little easier to pick out your scientific interests from the haystack of the ZTF alert. So like if I only want type 1a supernovae with at least 20 detections, that's very straightforward to set up a filter that'll do that. So I'll run that query, and that quickly returns a lot of results from Alerce. I can go look at those alerts on Alerce. I also like Alerce because they have a dark mode. Nice. So I can assess this target, whether it looks interesting to me. It does. It's definitely a supernova, clearly in a galaxy. So I'm going to go ahead and add that target to my Tom. So again, similar page as before. It went and pulled the RA and DEC. You can add it to groups if you want. I scroll down to hit submit, and that'll make a new target page. Once again, since there was a ZTF name, it automatically pulled in the ZTF photometry, so you can see there. If I want more observations, this was something that we saw in David and Curtis's talk yesterday. This has again been customized considerably to like kind of a default set of filters and exposure times that we typically observe supernovae with at LCO. So you can get a kind of standard observation with one click if you want. If I want a Gemini spectrum, I can do that as well. I've also customized this considerably, made it a little more user-friendly. There are some plots up there to assess observability, and then this is all you need to trigger Gemini. So let's say I want Gemini South within the next day. It's slightly high air mass, so I'll increase the limit there. There's its approximate magnitude. I can request whatever exposure time I want, whatever slit width I want for the Gemini spectrum. You can submit observations as prepared, which means it'll automatically trigger Gemini. I'm definitely not going to do that for this demo, but you can trigger Gemini without downloading the OT if you want. So that went and talked to the Gemini API. So just to prove that worked, I'm going to go look at my Gemini observing tool. And when I refresh the Gemini OT, you can see that the new observations for my object appeared in there with associated arcs and acquisition and the exposure times that I requested. So just to recap what we've done so far, we used APIs to find interesting targets using a broker. We used APIs to gather all existing photometry and get that all in one place. And then we also used APIs to trigger observation. So that's the power of TOMS, is that you can do all of that in one convenient system. I'm going to show one other thing. So I'm going to jump to another target here. This is stuff that another grad student in the group, Craig Pellegrino, has been working on. He's been working on making a lot of the pages, especially the data visualization pages, more reactive and interactive. So if I jump over to the spectroscopy tab, you can see I have a spectrum of this object in my TOM. You can plot spectral lines on there. This is all customizable. So if I put silicon on there, you can see some common silicon lines that are in supernovae. These two columns are redshift and velocity. So I can use this tool to do some rudimentary velocity measurements for supernovae. This is functionality that's basically in the TNS, but this is all replicated in Dash. I can also compare to other spectra that I have in my TOM. So if I know this object is a high velocity 1A, if I want to compare to another high velocity 1A that's in my TOM, I can do that, and it'll pull up all the spectra I have of that. If I limit it to the earliest spectrum of this other object, you can see that those silicon features match pretty well. This is all a work in progress. You can imagine extensions to this, like you take a spectrum and your TOM automatically says, hey, that looks like this other object that you already have. Or you take a classification spectrum and there's integrated supernova classifications in there, or integrated general object classifications.
2 minutes.
Great, thank you. Let me exit out of this video and try to advance. Cool. Okay, so just to reiterate what I said, because I think it is very useful, is that TOMs utilize APIs to achieve science goals. So in that example there, again, we used an API to interface with a broker to pick out the needle from the haystack, find targets that were relevant to my science interests. We used APIs to grab all existing photometry that I could find and collate that in one place. And then we also used APIs to trigger more observations. SNEX2 is all open source. It's on GitHub, so there's the link there. If you're interested, if you're a developer, especially if you're a TOM developer, feel totally free to go there and check out the code. There's me in OctoCat form, as you can see. And that's it. There's my email. Thanks, and we'll take any questions.
We have about a minute left if anybody has a question. All right, well, thank you, Jamie. If folks have questions, you can post them in the Slack.